to the 6th lecture, in which we'll go through Kirchhoff's voltage law. I'll write here actually KVL as an abbreviation. So the Kirchhoff's voltage law is actually a law which describes the voltage in a circuit. So usually when we have a circuit like this one, we have a voltage source feeding 3 resistors, R1, R2, and R3. And we said that in the last lecture or the one before, I don't remember, but we said that each resistor has a voltage drop. So R1 has V1, R2 has V2, and R3 has V3. And you see on the sign that it's first positive and then negative. So it means that we go from positive to negative. It's a drop, right? It's a negative. So it means we have a voltage drop. That's also the name telling us that. So we're actually losing voltage. So, but the Kirchhoff voltage law is stating that we can start from here. So it's saying that the total voltage V here minus the sum of individual voltages like V1, V2, and V3 with this I here is saying that the total voltage minus the the sum of the components voltage drops is equal to 0. Another way of saying that is to have this formula here. On this equation, we say that the voltage minus V1 minus V2 minus V3 equals 0. So it's the same thing as saying the total voltage minus each resistor's voltage drop or component's voltage drop equal to 0. Their voltage. So we have that. Okay. And now we say that the voltage actually can be rewritten in Ohm's law like this, right? Voltage equal to resistance times current. So we say that V1 can be rewritten as R1 times I, and then V2 as R2 times I, and then V3 as R3 times I. So we just plug that in, keep everything as the same. And then we come to this equation here, or this equation. So we say that the voltage, if we move everything to the other side, so we move this to this side, so we see that the voltage is equal to R1 plus R2 plus R3 times the current, right? If we just move this into brackets, the resistance. And what's really good here is that if I move this one a little bit, because I want to put something in between here. So we say that we can compare this. So we see that this term actually here is the, as we used to call it, the total resistance. If you pay attention to it. So you see that the voltage equal to R total, which is this term, times the current. So we actually verify that with this formula, or with this Kirchhoff's voltage law. So then we come to this one, which says that if you want the current, we just divide the voltage with the total resistance, which is R1 plus R2 plus R3. I call this R total here, just like that. So we have proven actually that, basically what we have proven here is that with this formula, Kirchhoff voltage law, we can say that in a series circuit, as we have here, the resistors can be added together. Basically, that's all we're saying. Because we're saying that R total is the sum of R1, R2, and R3, right? This is exactly what we're saying here. I know it's getting a bit messy, I'm sorry for that, but I hope you get the point, which is that R total is the sum of R1 and R2 and R3, and the current is the same, the voltage is a total, so we get the total resistance. So we basically just proven that, and we can add them together and get R total. So let's, recap this session. So we say that KVL, I'll call it that for now. So KVL is Kirchhoff's voltage law. So we say that KVL means that R total, the total resistance in a series circuit, okay, I'll write it like this. R tot in series circuit is equal to the sum, yeah, let's say the sum. This is the sum symbol, so meaning the summation of the elements. I just call it I, so I is the increment, right? So R1, R2, R3 up to whatever we have. So R2 in series circuit is equal to the sum of all resistances. Does that make any sense? I hope it does. So this is a series circuit. I need to point that out. This is very important. Series circuit, which means one current. One current or one branch. Actually, let me write that. So one current or one branch. Okay, so that's one point. Another point is that we say that with KVL, we say that the applied voltage V is equal to the sum of each voltage drop. So I just say the sum of VI, right? And we said that from this, we also said that the total voltage minus the sum of individual voltage drops will be equal to 0. I mean, this will of course be the same. So yeah, so that's what we're saying, that the total voltage is actually divided. So total voltage is divided between each connected component. I think that should make sense. So total voltage is divided between each connected component. So, and as we know, what is the value actually for voltage? Some might say, how can we know which value will be on each component? How do we know that? What is the value of the voltage? We know that by Ohm's law. So if the current is always the same, we know that the resistor is the only thing that is changing actually. So if the resistor is changing, it means that if the resistor is very high, we also get a rise to a high voltage, right? So the voltage drop, V drop, will be higher. Considering the current is the same, which it is through the whole series circuit. So that's good. So we have that there. Is there something else? I mean, KVL is, yeah, I think this is the main thing. This one is like a byproduct of it, kind of, with the current being the same and resistors added in a sum. Yeah, I think that's pretty much what the formula tells us. Yeah, so the main thing is really that the voltage is divided, I mean, on each component the voltage drops, but it's actually depending on this value here. So if resistance is high, it will be more more voltage on that component. So I'll just do this quickly. Let's see here. We have this circuit. So we have 1 kilo ohm, which is 1000 ohms. Okay, and then we have 10 kilo ohm, which is 10,000 ohms. So here we have I don't know, let's say 100 volts. So across here and across here we measure the voltage drops. So across the first resistor R1 and R2, okay, so across R1 we have a much lesser voltage drop. Actually 10 times lesser voltage drop. Because we say that yeah, so V1 is equal to R1 times the current. Current is the same. V2 is R2 times the current. So if V1 is just R1 times the current, and then V2 is actually 10 times R1 times the current. So you see that if these all are the same, we see that Yeah, so basically you see that V1 is equal to 10 times, actually V2 is 10 times V1, basically.